So now that you have completed number 5 and number 6, you can check your answers. And then we can turn the page to complete the opposite side's notes. Again, find the diameter and radius of the circle with the given circumference. But if we look at our 3 examples, we are now given the circumference in terms of pi. So this type of problem will be done in the same way, only our answer will look a little different. Again, the circumference is 18 pi. We know, I will write the formula up here, circumference equals 2 times the radius times pi. So I will replace the c with 18 pi. 18 pi equals 2 times the radius times pi. If I divide both sides by 2 pi, you will see over here 18 pi divided by 2 pi is going to become 9. So the radius is 9. 18 divided by 2 is 9. Pi divided by pi is 1. So if the radius is 9, then the diameter is 2 times those, which is 18. You may try number 8 and number 9 on your own, and we will check them in class. I'm going to move on and complete the worksheet with you now. In number 10, a square is inscribed in a circle. Find the exact circumference of the circle. So let's talk about some things we know about a square. We know that a square has all 4 sides equal. Here's a new word, inscribed. A square inscribed in a circle means that the 4 vertices of the circle are exactly touching, and all of the interior of the square sits inside of the circle. So that's what it means to be inscribed. 4 sides equal, right angles at the corners. And so what we have here is a right triangle. Actually, it's an isosceles right triangle. In order to find the circumference, we need to know what the hypotenuse is of this right triangle, because that's going to be able to tell us what the radius or diameter is. And so we're going to have to use the Pythagorean theorem. I'm going to put an x here and an x here, and I'm going to write my equation. X squared plus x squared equals hypotenuse squared. Now, we know what each of the sides are because it's a square. So I can take those x's and write 3 squared plus 3 squared equals h squared. 3 squared and 3 squared is 18 equals h squared. And so h is the square root of 18, which the other day we learned how to break down the square root of 18 into square root of 9 times the square root of 2. Three square root 2. So the entire diameter of this circle is 3 radical 2, because the diameter of the circle is also the diagonal of the square, is also the hypotenuse of that right triangle. And that is 3 radical 2. So if we're going to determine the circumference, let's use the equation diameter times pi, since we already know the diameter is 3 radical 2. And so my exact circumference is going to be 3 radical 2 pi. Number 11. A rectangle is inscribed in a circle. Find the exact area. Here's my rectangle. Again, inscribed means that the figure is sitting exactly inside the circle with the vertices touching the circle. It's a rectangle. Well, you know some things about rectangle. Opposite sides are congruent. You know that you have right angles. You know that you have right triangles. In order to find the diagonal of the rectangle, which happens to be the diameter of the circle, we need to do the Pythagorean theorem. 8 squared plus 15 squared equals c squared. 64 plus 225 is 289. And so when I square root, I get 17. So 17 is the entire hypotenuse. 17 is the entire diameter. If I want to know the radius, I need to take that 17 and divide it by 2, and I get 8.5. So to calculate the area of my circle, it's going to be radius squared times pi. And again, it says exact. So notice when it says exact, I am not typing in my pi as 3.14. So this is going to be 8.5 squared pi. And so we're going to come to our calculator, and we're going to go 8.5 squared, which is 72.25, and then I'm going to leave pi in my answer, 72.25 pi feet squared. And that is the exact area of that circle. The last topic in this lesson is what happens when I have a right triangle inscribed in a circle. So I'm using that word inscribed again. Inscribed means that all 3 corners of the object are touching the circle, and all of the object is contained inside the circle. Now, in order for a right triangle to sit in a circle exactly, it only happens if the hypotenuse is the diameter. The only way a right triangle sits precisely in a circle is if the hypotenuse and the diameter are one and the same. So angle D is a right angle if and only if AC is the diameter. So we can again use our knowledge of right triangles to do calculations on circles. So if you look at number 12, find the exact circumference of the circle. Well, let's take a look at the circle. We see that we have a right triangle inscribed in our circle. We see that the diameter and the hypotenuse are one and the same. In order to find the circumference, we need to know the radius or the diameter. And so we're going to do our Pythagorean theorem. 7 squared plus 24 squared equals c squared. That's 49. That's 576. So that ends up being, let's check that out, 7 squared plus 24 squared is 625. And if we square root that, we see that 25 is the diameter. So this whole diameter is 25. And so if we're going to go calculate the circumference of our circle, we're going to use diameter times pi. Radius times 2 times pi also works, but if we're given the diameter, this is a shorter way. The diameter is 25, so the exact circumference is 25 pi. And there are no units given, so we'll just write U.